Let's talk about foreach. So we'll take a look at a couple of lines of code in Visual Studio. And we'll start with a data structure, and this particular data structure will be the simplest, an array of integers. So as I said, this is the simplest data structure, an array of integers, but this could be conceptually any data structure. This could be an array, as you see here, or it could be a stack, or it could be a queue, or it could be a linked list. It could be a dictionary, or it could be a database. So it's really just standing in for the idea that I've got some collection of data. And I want to process that data. Now, if we were to process that data using a for loop, it might look like this. So of course this loop is going to print out all the values of the array list. And that might very well be sufficient for your purposes. However, it's also possible that you don't really want to get involved with the gory details of how the data structure is created. In this case, the fact that it has an index that goes from 0 to 1 less than the number of elements in the array, which is to say something less than list.length. So to abstract ourselves away from those details, C# has given us what's known as a foreach loop. So I'll repeat the loop as a foreach. And in this case, I simply say that the data structure is made up of elements or constituents or components or pieces or members, whatever you want to call them. So in this case, each member is an integer. So I will say for each int. And since this is in fact an array, I will call these elements in my data structure list. So you'll note that I'm not getting involved with the, as I say, the gory details associated with the fact that there's an index and we iterate through that index or anything along those lines. I simply say that I have a data structure and each of its constituent parts can be treated as an int. And then I allow C# to do the rest of the plumbing for me. So the two loops that you see here are functionally identical in that they print out all of the elements of my array list. Obviously, with a for loop, I know a little bit more about the data structure. For example, I couldn't necessarily do this with a stack or a database. So that has to be an array. What does the data structure have to be usable in a for each loop? The data structure has to implement something called IEnumerable. There's also a generic version of that. We're not going to really get into that here. I'm just going to say that there are some requirements for the data structures that you can use in a for each loop. However, those are pretty loose requirements because you will find that most data structures, in fact, do implement IEnumerable. Okay, so that's the for each loop, and that seems so great. Why would we ever want to use a for loop again? And the answer to that is because there are a number of limitations associated with for each loops that may not be appropriate for your application. In particular, for each loops are read-only. In other words, I am not allowed to change element and I'm not allowed to change list during the execution of the for each loop. And you can imagine that if you could change the data structure as you're looping through it, it would be very difficult to construct code that would make sure you get all the elements. For each loops advance one element at a time. In other words, you can't skip around. It's not random access or discontinuous access. You get one element one at a time, and you process that particular element. Often that's what we want, and so for each loops work fine. But in the case where you need more flexibility, you're going to want to use a for loop or some other sort of control structure. For each loops also move in the forward direction. In fact, it's a little bit more than that. If the order in which the elements are processed is really important to you, you probably don't want to use a for each loop, except in some limited cases. So in this case, where we're printing out the elements of an array and we really don't care what order they're in, for each loops work fine. On the other hand, if you needed some other kind of behavior, you may be able to use a for each loop, but you also might not be able to. Let me give you an example of that. If I wanted to, for example, go in the reverse direction with my for loop, it would be a matter of changing the condition like so that we can reverse the order in which we process the elements. On the other hand, with a for each loop, that's not necessarily possible. In the case of an array, it actually is, because we can call something called reverse. And that will actually allow us to iterate through the loop in reverse. On the other hand, there are a number of data structures that do implement IEnumerable, but do not support reverse in this way. For example, there's something called an array list. And I can add elements to that array list. And I can use a for each loop to process those elements. And that would process this collection 100, 200, 300, 400. If you would like to go in reverse, you will find that there is a reverse method, but it is not constructed in such a way that you can use it inside of a for each loop. So in fact, this won't work. On the other hand, if you reverse the list first and then use it in the for each loop, it will work, and your answer will be, as we can see here, those values in that array list in reverse order. So I think the takeaway here is that if you do want to play with the order, in this case reversing the list, that's really something done outside of the for each loop. The for each loop itself moves one element at a time and in the forward direction. And lastly, as a limitation to for each loops, for each loops do not provide an index value. So again, as we look at our list here, we're not really thinking whether it's reversed or not is immaterial. We're not really thinking in terms of what the index value is. We're saying just give me an element of the list. So I don't know what the index value of that is, and theoretically it might not have an index value because of course we might not be dealing with something as simple as a list of integers. So for each loops do have limitations. There are times when you won't be able to use them, but for those times when you are, they make code cleaner and more robust by separating the implementation of the data structure from our ability to process each element. And that's for each loops.